The information presented is for informational purposes only. The opinions expressed are not necessarily the opinions of any Daikin company. This information should not be confused for accounting, legal, medical, or other professional advice. Please seek advice from a qualified professional for any specific questions.
Welcome to the Accelerated HVAC Success Program. My name is Ben Middleton. I'm the National Sales Training Manager for the Goodman, Amana, and Daikin brands. Today we're joined with John Ellis with the new flat rate. John, thank you so much for joining us.
Hey, thanks for having me.
Hey, we wanted to talk a little bit about indoor air quality today, which has been a passion of yours for a long time and is in the last several decades has been a big point of interest in the HVAC community.
Absolutely.
So let's talk a little bit about how did you get involved in indoor air quality and make that bridge in your HVAC career?
Well, Ben, I owned a HVAC company in California, and it didn't say heating and air conditioning on my trucks. It said performance contracting. So I've always been in that kind of realm of the high performance and measuring and commissioning. And then I had an opportunity to work with some individuals there who were deep into the indoor air quality space. They mentored me and brought me along, and there was just such a great fit between the HVAC components and system performance and building science into the indoor air quality. And I got to work with some amazing clients and really just take that journey and do some great projects and helping families. And so that was kind of the roots of how I got started.
Well, and I think that's one of the keys there, right, is helping families, helping people solve problems that they have.
Well, at the end of the day, we're all connected. And, during my training, I like to call that the human element because we're all connected. And yeah, we want to be profitable and make money. But you know what? When you can genuinely help a family, that's just very fulfilling for an industry person to really genuinely help families, especially when young children are involved. I did a lot of projects with children, and it's just a great feeling. And, of course, there's profit there too, but that's secondary.
Well, bringing up the whole profit area, I think we'd take a look back at just this recent season that we've been in with the pandemic and everything that was happening. We saw IAQ sales for many contractors just skyrocket and go through the roof. And I think IAQ has always been kind of this little area within an HVAC business where we can see profitability. But are there sometimes, is IAQ a one-size-fits-all, or is it, you've got all of these great, should everybody have every IAQ device in their home? How do you approach that? Because, I've seen all kinds of different things, right? Put a UV light in every single home. Or go ahead and make sure that you're offering this particular filter on every single install that you do. And those do make a difference, but how do you navigate that, and how does somebody really know that they are, in fact, making a difference in that home?
Well, there's a lot there. Let's see if we can unpack that a little bit. So we started off with you asking the question about the profitability, and the pandemic. I mean, thank goodness, I think it's in our rearview mirror. But that sparked an interest in IAQ from many directions. One, homeowners were home and spending a lot of time at home because they were on lockdown. It's like they look around. It's like, oh, hey, you know what? That wall's kind of dingy. I think I'll go paint. Or, hey, that remodel project I've always wanted to do, or that DIY project, now I have time to do it. But also being home, they're like, you know what? It's a little stuffy, or it's dusty, or, hey, you know what? I'm sneezing more at home here than I was at work. And so that kind of created that interest. Now, this is where it gets tricky because, yes, there was a lot of profits for contractors for selling products. And I got to be careful here. So then selling products wasn't necessarily a solution. There was this mindset that we could insert name of product here and everything is going to be fine. not truly understanding what it was the customer or the client was experiencing, and then being able to create a solution that was tailor-made for what they were feeling. So yes, profits skyrocketed, but I don't know if we genuinely were fixing a lot of problems. And so part of what we like to do in the contractors that I work with is let's create a solution. Let's sell a solution to the customer, or allow them to buy a solution, if you will. And it's got to be tailor-made, and it's not cookie cutter, one size fits all. And that's, I think, a mistake that has been made. And it's in part because of marketing. You know, marketing is tricky. We get bombarded with marketing from the time we get up to the time we go to bed with every product and everything imaginable. And our minds can only handle so many bits of information at one time. And so then we think because we're marketed a certain set of results that it's got to be. And it's just not true. And unless you've got a solid approach on how to really figure out solutions that are tailored for the customer, we can just sell gadgets all day long.
Well, and speaking of marketing companies, in the late 90s, early 2000s, there was this little company called Sharper Images, and they created a product, a room air purifier that they put out there.
Yep, called the Ionic Breeze.
Yes, it was the Ionic Breeze, and they actually grossed revenue of over $1 billion in that particular product. But they put out, again, great marketing and advertising. So we know that there is demand from consumers out there. I'm thinking even right now, if you look in the upper Midwest, to kind of bring things relevant, there's a lot of people thinking about air quality that are up in the upper Midwest right now with all the smoke coming in from Canada.
Yes.
And I know people are having respiratory events because of that. There's allergies that are being exacerbated. There's all kinds of challenges that are happening with that. And so there are some marketing agencies or organizations that will take advantage of it, versus when we take a look at the HVAC industry, so going back to furnaces and air conditioners, right? Why doesn't everybody just sell a 5-ton air conditioner and just go and market that and say, I'm going to give you cool air? Well, it's not going to work. And so the same thing kind of happens when we look at indoor air quality. And there's an acronym that you use in your class, I know, that you put out there, and it ties back into IAQ. Can you talk a little bit about that?
Yes. But first and foremost, you know, Sharper Image was a cool store. It was actually the brick and mortar Sky Mall with all the cool stuff. And they are no longer because of a lawsuit that happened with, you know, the Ionic Breeze. But so the acronym that I use, and Ben, you know, I got to give props. I kind of adapted that from you, but IAQ, indoor air quality, and I equate that to investigate, analyze, and quote. It's a 3-step process. I suggest that you do all 3. You can't skip one. But our industry, where did they go? Right to the quote. As soon as they hear indoor air quality, they associate that with a certain product, and it can be whatever the best deal at the supply house is, and they put it on the technician's truck and says, hey guy, I got a great deal on these. I want you to sell one on every job. And so we go straight to the quote without the investigation. So the investigation process is going in and through a set of measurements, doing building forensics, if you will, figure out the problem, take that investigative data, analyze it, and come up with a solution that you can quote to the customer based on data.
And, you know, I bet we both could sit here and talk for hours about stories where we have walked through that process. And really, this is where our industry becomes fun, because it truly creates life change for those that you go out and do the process. I remember one customer that I worked with up in Minneapolis. Daughter had severe allergies and a medical condition that was preventing her from actually being at home most of the time. She was spending a lot of time in the hospital. And so we were called out there, and just kind of to shorten up the story, we did the investigation process. And we found out the house was in a negative pressure, like many homes that are built today, because they are so tight and you have all these ventilation fans in there. And they were storing some chemicals in the garage. In fact, there was a big sale on fertilizer, and they had a pallet of fertilizer for the lawn sitting in the garage. And those chemicals that are used in that fertilizer were actually off-gassing and being pulled into the house. As soon as we removed the source, which you can't really get paid for telling them to remove the source, but removed the source, then we corrected the pressure in the home with an ERV and brought that in to give them the proper pressure in the house. Those two acts changed the whole entire dynamics of the home. And her symptoms went away like that overnight. And it's just those little tiny things, but you have to have that investigation process. And I'm sure you've got many stories. I know you tell a lot of stories in your IAQ principles class that you do for us.
Yes, and that story, Ben, can be duplicated in any state in the United States. West Coast, East Coast, Minnesota, Texas. That scenario can be duplicated in those set of circumstances over and over again, and I see them a lot. And you mentioned something about the source, and I drive this home in my class: source control, source control, source control. If we can identify the source of the pollutants and get a handle on that, the rest of the stuff becomes easier to do. But that's a big thing that I like to drive home, pollutant identification and source control. So I've got wonderful stories. I've been able to work with families all over the United States, so it's awesome.
So when you talk about source, so we identify where the source is. Source can be something coming from outside, outdoors, like the smoke that we have right now in the upper Midwest with the fires that are going on right now. It can be internal, so you bring a brand new piece of furniture into the house and now you have off-gassing going in there, or the paints that you use in the home, or the flooring that you put into the home. There's so many different types of sources that you can have that are going into the space. And then there's different things. Probably the biggest thing, right, is to remove the source if that's possible. But then what are some of the other strategies that you have to remove the impacts from that source if you can't remove the source from the home? What are some of the main strategies that you use when it comes to indoor air quality?
Yeah, that's a great question. And, we're speaking primarily to the HVAC industry. And so there's some key principles that I like to drive home in my training that is already part of our everyday HVAC businesses, which we can get a good grasp on to allow us to have a great IAQ approach. And so first and foremost would be thermal comfort. We are in the comfort business, so let's get a handle on thermal comfort. And that's very important. And people say, oh, well, with thermal comfort. But you know what? There's a lot of conditions, medical conditions, that can be aggravated just by thermal comfort. Too hot, too cold, and different things. Second would be filtration. Now, every piece of equipment we put in should have some kind of filtration on it, and that runs the whole gamut of what that could look like. But the better the filtration, the better chances we have of removing particulates in the space. But it's got to be designed into the system because, for everything we do, there's an action and reaction. And unfortunately, a lot of people put a great filter in, but it's not designed, and then all of a sudden they're having system performance problems. My third approach would be ventilation.
Well, let's talk about filtration real quick. We'll get
Sure.
to ventilation in a second.
Yeah, absolutely.
So they rate filtration, right? They have a rating for it, and they use the MERV scale for that. And when I used to talk to contractors all the time about filtration, I used to say, the best filter you could use would be a piece of plywood or a piece of drywall. Just stick that right in there; it'll stop everything. But then, to your point, we have to deal with static pressure, right? Because the whole entire HVAC system, its job is to move air. And so you also have to look at that pressure drop across the filter, because as you go up, typically in MERV rating, you're going to restrict airflow more and more and more. And so talk a little bit, what is MERV rating?
So it's a minimum efficiency reporting value. Yeah, almost got me. Yeah, so and that's MERV. And so what that entails is both airflow through the filter, and it's called a spot arrestance. And what they do is they release a known amount of particulates, usually in weight, at different sizes, and then they're able to capture them on the other side, and then they do a measurement on that, and that's the elevator version on how the MERV rating is given to a filter. But what happens is, again, as typically the higher the MERV rating, the more resistance. So we need to move a certain amount of air at a certain velocity through a certain amount of net free area through that filter and maintain a certain amount of CFM airflow for our system to work, both on a refrigeration cycle and or the heating cycle or air exchanges per hour. All those things are factored in. So there are products out there that have high MERV rating with a lower static, but they start to get bigger and bigger. Right, and so then and sometimes they can't fit in what this system allows, and there's 1 inch high MERV and they just kill the system,
right?
Or there's a 4 or 5 inch extended pleated media with a higher MERV that give you a little better result on the performance side. But that's the go-to. That's the standard we have to look at how a filter is rated.
So when contractors are looking at the filtration side, they got to keep those two things into account. They got to look at the pressure drop across the filter, look at the MERV rating, and they're trying to get that balance right. They're trying to get the combination right. But the other thing is, filtration doesn't work unless the fan's on. You can have the best filter in the world, but if you're not circulating, moving air through that, it's not going to do anything to remove those particles from the space.
Right, you might as well just leave it in the box.
Right.
At that point. Yes, and so we have to be careful, and that's and you are absolutely right. If we're not moving air, we're not removing particulates. Certain climates, though, if you circulate the air, and we are in Houston right now, and some of the more humid climates, that can cause a problem too. So we have to be careful. I'm all about circulating the air, definitely. But then, you got to know your marketplace and your climate, if you will, too.
Well, and I think we're going to talk about humidity a little bit later, but you were going into ventilation and talking about ventilation in a space, which when we talk about HVAC, the V stands for ventilation, and I think there's some sort of an industry joke around what happens when you remove ventilation from HVAC.
Yeah. You become a hack, right? Is that where we're going with
Yes.
that? Yeah. Ventilation is a key component of IAQ. I think ventilation is a key component of just, having a good system. But how you do that is vary. So I always say, hey, the why never changes across all climate zones, just the how. And so we did thermal comfort, filtration, and then ventilation would be key. Ventilate. And so why do we do that? Well, one, we want to bring in, finger quotes, fresh air or outside air, and that helps us work with pressure differentials within the home. But there's also a saying that dilution is the solution for pollution.
Yeah, it was an EPA quote that.
That's probably the bigger component of that.
Right.
And so as we look at pollutant sources within the space, and can we remove them? Sometimes we can't. Sometimes there's behavioral. Sometimes there's things going on in the home that we really just don't have. It's out of our control. So the good approach for that was, let's bring in a certain amount of outside air to dilute those pollutants. Carbon dioxide is a good one, and TVOCs also can be diluted and brought down to a safe level. But always, we want to try to identify the source first. But ventilation.
So we've filtered the air. We've diluted the air with ventilation. Another way would be removal of some of those gases through absorption. And so talk about absorption a little bit.
Yeah, and this is widely misunderstood in our industry. You can go to any supply house now, and you can buy a charcoal impregnated filter. And by default, it's carbon, but it's basically burnt coconut husks. And they harvest that charcoal and they impregnate a filter, and it's so thin because we still have to get air through that filter.
Right.
And it's got a huge resistance, a static resistance. But any kind of absorption properties that are in that charcoal based on humidity and time of use is gone within a couple of weeks. And so now you're just, you basically put a sail in your filter. So we have to understand what actually is involved in true absorption. And so that would be activated carbon. And so activated carbon is a process which the carbon pellets are actually brought up to a temperature, cooled down. They treat it with argon and nitrogen, and then they superheat it again. And as those molecules expand and contract and rejoin, and they remove the argon and the nitrogen come out of it, now you have a carbon that's ready to absorb. And so that is true absorption. And we just don't really get a lot of that out of a charcoal impregnated filter. But yet that's what we have. That's what's at our disposal. Hey, it's on the shelf. Carbon's got to be good. So we really have to be careful, because we might be overpromising on a product that's really not going to deliver what we think it can. Does that make sense?
No, it makes a lot of sense. And I do know that Daikin's been working with a lot of other surfactants and looking at some different ways, especially in our commercial spaces, where we can use those through wheels, where you're actually off-gassing into the free air and then, recharging that, so that when it goes back into taking the air from the building, it's actually helping with that whole entire process. So absorption is another great way to help remove it. But to your point, it's got to be done the right way in all of these solutions, right? It's not a one single fix, the magic bullet that we're going to put out there and it's going to do things. Talk a little bit about PCO technology and photocatalytic oxidation and some of the things that are happening there.
What would you like to know? So if we want to break down the technology, so I teach this in my class, and I try to be careful, and I don't name names of manufacturers or different things, because the technology is the technology. And so I try to drive that bus right down the middle. And so we have to look at the science behind the technology.
Correct.
And then we have to make a decision based on that information, if this is the best approach for our clients, and is it really going to do what we think it's going to do. So photocatalytic oxidation is basically there's a substrate, and it's titanium dioxide.
Right.
And it has UV that interacts with that. During that interaction, it creates hydroxyl radicals, and they're just that, they're radical. And so as they produces hydroxyl radicals, the assumption is that certain viruses, bacteria, and pollens and different microbes will attach to the hydroxyl radical. And because it's so radical and it breaks down so quickly, it'll break down that with it. The only problem is every action, there's a reaction. I've said that a couple times now, is that there's byproducts involved.
Sure.
And it's no secret. I mean, if you do some digging and look at some of the peer reviews and some of the scientific papers, with a photocatalytic oxidation process creating the hydroxyl radicals, there is also creation of formaldehyde as a byproduct. There's also creation of carbon dioxide. And there's also the creation of nitrous acids. And so everybody, well, not everybody, a lot of people say, well, they're just trace amounts. Well, okay, can you measure it? How much trace? And if you're dealing with a client that's severely compromised, is that enough to upset the balance? And so my thought is, and my approach is, I don't use anything that is going to put an additive in the air as part of my solutions. Because we can address the things that PCO says they're going to address in different ways. And then the other besides PCO is ionization. And there's companies out there that do them both. Hey, we're going to do a combination of the two. So ionization, I understand it at its at the principles of it, but basically we're putting positive ions into the air, and they exist naturally anyway. And so what happens is opposites attract. And so you've got particulates in the air, and they will start to stick together because of the ionization process. And so you have a positively charged looking for a negative, and they stick together. So here's the drawback. And then it's said that it'll increase your filter efficiency. There's peer reviews out there that says it's negligible. They don't see any measurable difference in filtration. So you have particles now that are in the air, they're charged, and they're clumping together. And so the principle is they fall to the ground and or get large enough to get caught in the filter. And And it's up to us as the occupants of the building to vacuum them up. Here's the problem. Anybody with young children play on the floor. That's where they live. Children are on the floor. Those particles that are now charged fall to the ground. That's where our kids are. They have the ability to breathe them in. It's a charged particle, and so now we've got a problem with that. And then the other problem is if we've got a charged particle in the air and it needs to get to the filter, what's in the way? We are. And so I understand the science behind it, and I understand what they're saying it will do. I'm not totally sold on that. And here's another thing. So particulates in and of themselves are a problem of all different size ranges. We get them all clumping together, we're creating superparticles. It's a toxic soup of particles that we're creating because they're all joining together. Now, is that any worse than just breathing them individually? I don't know. And there's not enough research out there to look at the long-term negative aspects of ionization and PCO technology.
Well, it's interesting because none of this technology is new by any means. In fact, manufacturing facilities have been using ionization forever just to try to keep the manufacturing space clean. Mm-hmm. And I've been in a couple of manufacturing facilities where they have these huge ionizers on the sides of the walls, and they have told me where they've actually seen clouds of these huge masses that just form in the manufacturing, just kind of looming over of this mass of dirt, dust, and particulate all together. And so you're right, to your point, it's designed to clump it up and capture it on the filtration substrate, but you do get stuff that forms out into the free space. And so there's challenges, there's issues with that when you look at it. But it's good to understand all of these, because in our industry, things get thrown around all the time, right? Somebody comes in and they've got a brand new product, and they're going to say, we're going to talk today about PCO technology. We're going to talk about ionization. We're going to talk about ventilation. And so we've talked about, chemical reactions. We've talked about, physics with ionization and what we can do there. We've talked about filtration. We've talked about dilution. And so talked about a lot of strategies for this source control, right? Removal of the source. The other piece in IAQ is humidity.
Yes, huge. Now, again, the why never changes, just the how. Mm-hmm. I'm from the dry climate. And, I had my business in California. We don't have a lot of humidity issues. And then I get made fun of. Oh, you dry climate guys. So I had to get on the fast track and learn, because I'm working now nationally. And so, yes, humidity is huge. And how you control humidity, whether it's through the latent side of your system, may not be enough. So you got sensible latent, your air conditioning doing work. One, we're changing temperature, and one, we're removing humidity. And at some of the wetter climates, like Houston, the latent side of your air conditioning equipment might not be enough. And so now we got to look for an external, a standalone dehumidifying system. There are dehumidifying ventilation systems right now that are just amazing. So they're doing that work. We can bring in the fresh air, we can wring it out, we can filter it, we can get it into the house and use that for our dilution and or building pressures. So it's a big strategy. A lot of things happen with too much or too little humidity. We can go both sides of that spectrum. And so once you get too dry, we start drying out mucous membranes. I've seen veneer on cabinets start to dry out and peel because it's too dry.
Right.
And thinking, well, yeah, we want to upset the balance of our sensible latent in like California, Arizona, Utah, the dry climates, and it's like, oops, we went too far. So it's a balancing act. And then with that, too much humidity, we've got microbial growth. Dust mite colonies really thrive in a high humidity area, and just overall health as well. So humidity is huge strategy for us in the IAQ realm.
So what is the ideal kind of range for humidity? I think that's debated in our industry all the time. Where do you see kind of that sweet spot? Is it a wide? Is it a narrow band? Is there a practical range that you're trying to stay within?
Well, that's a great question, Ben. So just off the cuff, what do you think it is based on what our industry has told us?
Well, what I've always heard, and this comes back from the American Lung Association and the asthma associations of the world is they've always said, that sweet spot is 40 to 60.
Yep.
And but when you get up north into the colder climates,
Bingo.
It's really hard to maintain that 40 without having all of your windows rot out of your house.
Yep.
And when you come down into these humid areas that you may be, like we're in Houston right now, it may be very, very difficult to drop it below 60 and keep your energy, in a range, just trying to maintain that. So, do you have any thoughts or comments around that?
Again, the why never changes, just the how. So in those climates, Michigan, Minnesota, upstate New York, 30% in the winter is kind of where you're going to hang out. Because even just jumping into that 40%, the windows start to condensate, and so that's tough. So then again, the dry climates, 50, 60% is going to feel pretty nice because they're dry all the time. Houston and Alabama and Georgia and all the humid climates, maintaining 50%, it's going to be tough. Again, the energy usage, and so that's why having a standalone dehumidifier to do that heavy lifting will allow the air conditioning system to be able to work a little easier when it comes to controlling humidity. And then we also have to base that on what the client needs. So, I mean, it's one thing to have some industry standards and paint a broad stroke of a brush, let's try to hit this sweet spot. But what does the client need? And so anybody that's got any kind of respiratory issues or compromises like that, they'll know. Whether it came from their doctor or just living with that, they know where their sweet spot is. So we have to tailor our approaches towards the client and not just general numbers. Does that make sense?
Yeah. So we've talked about temperature. We've talked about all of the sources that we could have inside a home and source control, and then we've talked about humidity. Kind of the last thing, we get into safety, and we think about some of those gases that actually can be a real safety hazard to people. So two that come to mind for me are carbon monoxide and then radon, which are very prevalent in a lot of, it depends on areas for radon and where you're at. There's maps that you can look at. But how does an HVAC company impact those two gases?
So radon, it's funny. I ask my classes all the time, hey, anybody got radon in their area? Oh, no, we don't got radon. It's like, no, you do. It's everywhere. And so understanding, and again, you can go to the, radon/EPA.org, and you can put in your zip code, and you can see where those radon belts and where the hot spots are. So we have to understand, so radon happens naturally. It's radioactive minerals in the ground, and they get up through water, through basements, and through cracks and voids, but it's coming from the earth. So that leads into one of my other strategies, and that would be building pressures. And so when we look at building pressures, we're kind of dipping our toe into the building science side of things, which is okay.
Right.
But having a home in negative pressure is going to accelerate any kind of external gases. And so with those gases and VOCs, carbon monoxide, definitely I'm all about, and that's one of the first things that I always do is I check my carbon monoxide. We're going to check the operation of the gas-fired appliances, water heaters, stoves, different things. And so we want to make sure that combustion safety is always like top of the list. And that's right in our wheelhouse.
Right.
Everybody should be doing combustion analyzing on every system. And so once we get that, now we're looking at other things. So one of the key principles of building pressures is let's keep inside in and outside out. And so we've got a lot of external forces against us. We've got industry. We've got freeways and traffic. We've got agriculture. We've got radon. And so a good solid, now I'm radon certified through the Indoor Air Quality Association, and I've installed radon mitigation. The HVAC industry is like, that's right in our wheelhouse too, but a lot of guys shy away from it. And it's like, no, you should do it because it's a fan and it's PVC piping. Now that seems very simplistic. There's other things involved. But a good approach is if you install a radon mitigation device and you're pulling those gases out, making sure your pressures in your home would just help things. So keeping a slight positive pressure, or for sure not a negative pressure. And if you separate spaces, you can have a negative pressure in a basement or a crawl space in relationship to the house. So even if the house wasn't in a positive pressure, at least if that space is in a negative pressure, so there's all time, but pressure differentials is huge. And so that's, again, that's part of the building science things, and that's one of my 6 key principles would be building pressures for that reason. Let's keep inside in, let's keep outside out. And then radon is absolutely everywhere. It's the second leading cause of cancer.
Yeah. So we've covered a lot, and just as we finish up here, so let's get into that measurement side of things. So how do you go in? Let's go back to that investigation process, because we talked about all of the different things that we may have in a home. What are some tools that you would say would be a must for every HVAC contractor that wants to go out and truly solve IAQ issues for a homeowner, and not be the marketing person, that sharper images out there, but be a true professional and going out there and investigating and really understanding what's going on so they can provide the right solutions? What are some must-haves that you can think of that contractors should carry with them?
It's a great question. And, as HVAC guys, we love our tools and our toys.
Absolutely.
It gets pricey. So I break up my discovery into 3 pieces. So air safety, building safety, and mechanical safety. So there's three distinctive areas of concern. And with each of those, you have a certain set of tools that you need to be able to properly investigate. The air safety component allows us to see the unseen. And so there are tools out there that allows us to take air samples, and then 1 or 2 things, it'll analyze the data on the spot, or you take air samples, you send them to the laboratory. You can't fix what you don't know about. And so if you can identify the pollutants in the space, in the air, now you've got a direction to go. And so there's several devices, Air Advice, Air Answers. I work with a company, say, Got Mold, and it allows you to pull a sample, get it to the lab, and at least know if it's in the space, and then whether you need to go to the next level, which would be to bring in a CIH, Certified Industrial Hygienist, to really take it to the next level. But at least that's some preliminary information you have to come up with a decision. The building safety aspect would be the building science. So a blower door is important. Thermal cameras is important. Duct testing materials, because that can tell you if the duct system is inside or outside of the space, even though it's kind of HVAC, but it's kind of building science as well. Anemometers for pressure differences and being able to pressure map, moisture meters, so you can moisture map and different things as you're working your way out of a house. And then on the HVAC safety, all that stuff. So flow hoods, turning vane anemometers, combustion analyzers. Believe it or not, a particle scanner can work both on the air safety and the mechanicals, because now you can get a filtration rate. A true filtration rate, not just a pressure difference. So you measure particulates in and coming out,
right,
and now you got an actual filtration rate. And so all those tools, a lot of our HVAC brethren probably have all those already. But those are the 3 categories. And then again, you can spend quite a bit of money. It's easy to write a big check, but you don't have to do it all at once. You take a look at what you want to do and you pick and choose. So let's get started here. And maybe that's an Air Advice. And that gives us some information. And then as you go further in your journey, it's like, you know what, let's get us a good particle scanner that can read multiple size ranges all the way into the PM2.5 ultrafines. And so maybe that would be the next step. And then each time you go, maybe a multi-gas meter and different things as your journey, you got to start somewhere. As your journey goes further and further, you can buy more tools.
Well, John, we've covered an awful lot in this session. I thank you so much for coming in. If any of our contractors would like to learn more, you do the IAQ Principles workshop for us on the HVAC Learning Campus, and they can request to have that actually done in their area. And so you're traveling all over North America, working with contractors. You even do stuff one-on-one if somebody wanted to go into the Ask a Coach and go in and help with those really big problems and challenges that are out there. So I just want to make sure everybody knows that you're available as a resource to come in, do workshops in the local regions, and then also to help with some of those challenges that are out there. Thank you again so much for coming out.
Yeah,
I really appreciate you.